Good afternoon, everyone. I would like to introduce you to our project, which is focused on post-combustion capturing of carbon dioxide. The project is one of the main activities of our department. The name of our department is Department of Solid and Gaseous and Solid Fuels and Air Protection. Before I start, I must clarify several points. This project is co-financed or supported by grant from Norway government and subsequently by European Commission and concretely by European Fund of Coal and Steel. The basic question is why we are focused on post-combustion capturing of CO2. The explanation is quite simple. In Czech Republic, we have relatively dense network of existing coal-fired power plants and heating plants. Therefore, it is quite logical to try to incorporate carbon capturing system into the existing technology within its retrofitting. The schema on this slide try to clarify the position where carbon capturing unit should be installed into the existing technology. As you can see, this is classical coal-fired power plant using standard combustor incinerating pulverized coal equipped with boiler, producing steam. Steam is introduced into a turbine and using generator to produce electricity. Flue gas undergoes at first separation of dusty particles by electrostatic precipitator or baghouse filter, etc. Then the flue gas is desulfurized using normally using wet limestone flue gas desulfurization system, and then this is the place where we would like to install new carbon dioxide separation unit. At our department, we primarily pursue some activities focused on application of absorbent, of solid materials. Since 2015 until present day, we started experiments with a relatively wide group of possible materials. First materials were natural limestones. It was the subject of interest supported by Norway grant. After that, we would like to overcome some disadvantages of these materials using some improved materials like calcium oxide based adsorbents or synthetic hydrotalcid like compounds, etc. And presently we shift our attention from these, so let's say, more expensive materials to waste materials. And excellent example of these adsorbents or potential adsorbents are fly ashes and maybe bottom ashes from power plants. The slide shows you examples of some materials which are part of our sample base. and fly ashes are depicted on the last photo. During our project, we use, in fact, two types of laboratory approaches. First group is so-called main or basic characterization of sample. Second group of methods is based on our, let's say, self-made or self-constructed laboratory and pilot laboratory apparatuses. Regarding characterization of samples, we use a relatively wide range of instrumental laboratory methods, including elemental analysis, X-ray fluorescence spectroscopy, thermogrammetry, scanning electron microscopy, evaluation of specific surface, etc. But the core of our research is realized using three self-constructed apparatuses, which two of them are based on vertical fluidized bed reactors, and one of them uses, in fact, very, very similar construction, but is equipped with fixed bed reactor. On this slide, I would like to present you one of these apparatuses. It is namely laboratory system with quartz glass vertical fluidized bed reactors. This apparatus is optimized for roughly 20 grams of pulverized sample with a density equal to natural limestones or equivalent amount of another samples from our sample base. For detection of carbon dioxide, normal and typically infrared spectroscopy is applied. And now something about our results. Besides basic characterization, our main aim is evaluation of sorption capacities and especially their changes during cyclical adsorption and desorption process. Because especially natural limestones are very sensitive to sintering, causing relatively fast drop of capacity. And one of the possibilities how to prevent this undesired effect is some kinds of reactivation, for example, using high pressure steam. Or we can replace this more qualitative material with any waste materials, for example, fly ash, which is less expensive, but on the other hand, this material offers proportionally lower values of adsorption capacity. So, the project is still in progress, and I hope we will be able to present more effective values for industrial application within 1 or 2 calendar years. But at the end, I would like to clarify 2 things. At first, please do not ask me if our industry and power industry is ready to sacrifice about 20% of heat input to carbon capturing. That's the first point. And the second point is I am not climatologist, and therefore I am not able to answer the question whether human activity in industry is the main contributor to global warming or global climate change. I can only perform some experiments, and to compare sorbents. That's all. Okay. Thank you very much for your attention.